Good evening, everybody, and welcome to another vBrownBag webinar. Tonight's episode will be a continuation of our Python for DevOps series. This is the third in the series, and we're going to be talking with developers and learning how to level up our skills. Tonight, I am very excited to be presenting or hosting Calvin Hendryx-Parker. He is going to be talking to us today about AWS APIs with Boto3. Calvin and I met a couple of years ago at AWS reInvent. We attended a, what do you call those things, Calvin? The hackathon. The hackathon.
Oh, the hackathon too. Yeah, you're right.
We did a really super fun hackathon together, and in getting into the weeds with him during the hackathon, I realized what a genius he was, and that he absolutely needed to come and help present on Python and development and stuff. So a couple of years later, here he is. Yay! But before we get into that, let's go through a couple of housekeeping notes. Get in on the conversation. If you at vBrownBag or hashtag vBrownBag, I will be monitoring the Twitter feeds. If you have any questions, ping me either there or for the live audience attendees. In the Q&A panel, I will be watching all of that stuff and sending on the questions to Mr. Hendryx-Parker. So, without further ado, I know that you've got a ton of good stuff in there, so let me set you up as presenter, sir.
Sounds good. Thanks, Chris.
All right, you have the power.
All right, great. So I am super excited to be here. Chris had told me about this vBrownBag series multiple occasions, and I was excited to be able to help and participate, especially when he said he was going to start a series on doing Python for DevOps, which is primarily what we do. So again, my name is Calvin Hendryx-Parker. I'm CTO and co-founder of a Python and cloud expert consulting company called 6 Feet Up. So if you go to 6feetup.com, you can see some of the cool projects we've worked on and stuff we have done in the past. We're actually celebrating 20 years in business this year, which sounds crazy when I say it out loud, but it is true. We've been doing this stuff for 20 years now. So I wanted to go over some things today about getting started with using Python and the various libraries around AWS, including Boto3, and accessing the APIs that are provided by AWS with using Python and some of the command line tools. So I'll make an assumption that some of you are familiar with some of the command line tools, but I'm going to go ahead and show you a couple of cool things, maybe some tips and tricks you didn't know, and then we'll get into some Python code, and I'll show manipulating some data coming back from the APIs and basically give you guys some starter scripts for making your own command line tools on your Python journey. Helps if I click on my presentation. So to get going, we're going to do a couple first things first. I'm going to make, again, an assumption you guys have Python installed. We will be using Python 3, that is the Python, the only Python. Legacy Python, anything prior to Python 3 is being unsupported as of January 1st, 2020. So make sure your tools get updated or any libraries you're using are updated for Python 3. Make sure you email those authors. It's really important we get everyone on Python 3 moving forward because it will not be, Python 2 will not be supported. Once we get Python installed, we're going to talk about pipenv, which is what I use for managing our dependencies in our projects and our Python sandboxes for doing our code and basically keeping things separated. And then, step 3 is hopefully profit. But first things first, one of the things I really love to show people, and I'm surprised how many people don't know this, is there is an Easter egg built into Python, and I think it's really important for folks who are getting started with Python or even seasoned professionals with Python to try this little Easter egg because it does give you some little insights into the Python language. Oops, let me connect back to my session there. And so if I just launch a Python from my computer, not 3.4, and type import this, you will get the Zen of Python. And for the people who I teach Python to, and even for myself, I always tell them to print this out on a piece of paper, frame it in a very beautiful frame, hang it up in your bathroom, and whenever you're brushing your teeth or getting your self ready, read through it because it's more than just applicable to Python. If you actually read through some of these things, you'll see that they're pretty applicable to coding in general, and some of them are definitely applicable to life. So one of the things I really recommend to people is they read through this, kind of take it to heart, and make sure that as they're programming and coding in Python or any other language, that as you code with these things in mind, hopefully you'll end up with cleaner, more maintainable, more Pythonic code. So you may hear people refer to things as being Pythonic. And I think it's important to keep that in mind. So that is the first things first, is we should always do the import this and check out the cool little Easter egg in Python. And that's been in there forever. Another thing I love to tell people about Python, so people who are maybe viewing this webinar may not be familiar with the language itself, but Python itself has batteries included. You'll hear this phrase talked about a lot, and I think it's really important to note that this is a big differentiator for Python in the language, and a reason why a lot of people pick it up and start using it and really fall in love with it. And the batteries included is basically the fact that Python ships out of the box with a really robust standard library. And the core language itself is very nice, obviously, but the standard library has been one of the things that has made it really easy for folks to pick up and use, because without having to even install a third-party library, you're able to get actual work done, without having to import from third-party tools. If you compare and contrast that with something like JavaScript or Node, every little thing is going to require an npm install of some dependency, and that dependency may bring in 100 other dependencies if you're familiar with that ecosystem. But with Python, there's typically very little dependencies needed to actually get started. For example, there's a CSV parser included. I'm actually going to show you that during the slides in the presentation today. There's JSON parsers included. There's all kinds of tools built in that you're ready to go for you to use. So with that said, let's get started on how to actually get to productive work with Python. First, a lot of operating systems, especially Mac OS or Linux, ship with Python already installed, but you may want to use a freshly compiled, more current version of Python. So for example, on my Mac, I typically use Homebrew to install Python. So I recommend that for folks who are on a Mac. On Windows, you don't typically have Python installed by default, but you can go grab the installer from python.org, or you can use a larger package like Anaconda to bring down a Python that's got a lot of other additional included libraries for you. But once you do have that, and this is why I'm saying we need to be able to use tools like pipenv, is you're going to want to be able to sandbox your project from other projects you're working on. So for example, you may be working on a project that's using Django 1.8. It's an older but long-term support version of Django, but at the same time, you may have another project that's using Django 2.0, which is the most recent stable version of Django. You can't install both of those globally into your Python install, so what we need to do is basically create little virtual environments that you can install both those things into separate places. So that's what we're doing here. I was actually going to just show that off to you guys. So if we do Python 3, now, luckily, Python 3 ships with pip included, and because it does have pip included, we don't have to do anything extra to install third-party packages. Pipenv, the tool I'm installing here, is a third-party package, kind of an enhanced version of pip that combines the ability to install packages with the ability to make sandboxes, like virtual environments. So if we do Python 3 -m, which basically runs the pip module, and install, and this one here, install pipenv, we can, since I already have it installed, you'll see that it didn't actually do it, but this would install pipenv into your environment. 1 second here.
I will do some jazz hands while.
Oh yeah, thank you very much. Sorry, I just had to close the door there. It was getting a little loud downstairs.
No worries.
So now that we have pipenv installed, we'll be able to actually use it. So for example, if I go into my presentations here, this presentations folder has a pip file in there. So you'll see the pip file right here. That pip file defines for us some dependencies we're going to need to run some of the code that's actually in this presentation. And I'll put all this on GitHub so you guys can download it and play with it afterwards. But when we use pipenv, we can now do a pipenv install, and that will initialize our environment. It'll download any dependencies that are listed in that pip file and any of their dependencies. And it does it all in a sandbox for us, so that if we go into another directory, those dependencies won't be available to us there. So we've already got a pipenv environment. We can actually now activate that environment with this pipenv shell command. And you'll notice once we've done that, we now have in parentheses on your command line, on your command prompt, you'll see the vBrownBag. That shows us that we have our actual virtual environment active. So while we're in this virtual environment, for example, I know I have requests in that virtual environment. Oops, maybe not. I know I have Boto3. So Boto3 is importable there. If I deactivate and do the same command again on Python 3, so if I do import Boto3, this may work, because I have it installed in another environment. The idea there being, though, is we would typically be able to install different versions of those libraries into either environment.
And the border around the environment is the directory structure itself?
Well, no. So the border around that environment is actually hidden from you when you use pipenv. If I actually do this pipenv venv, I can see where that directory actually is. So it actually stores in a hidden directory in my home dir a automatically generated, like the name of the directory I'm in, plus some automatically generated temp characters at the end.
Okay.
And so I can do, for example, well, I won't destroy this one because I actually want to use it, but you can do pipenv --rm and remove that directory, and then in that virtual environment, it would be gone. And then you can reinstall, and it would create a new, fresh virtual environment for you.
Okay, I see. But in terms of creating a virtual environment, you do it by folder. You're using the folder structure to define your virtual environments. Right.
So if I'm making a directory called demo here. Oops. Demo. And if I do pipenv install, since there's no pip file here currently, pipenv will actually put a pip file here for me, create the virtual environment, and basically get it all fired up ready for me to go. So now if I do pipenv install requests, and as long as you use the pipenv tool to install all your dependencies you're working with, pipenv will maintain that pip file for you, adding in any dependencies along the way that you've installed. So you can see right here, it's actually installing the request library, which we knew wasn't installed in the other one, but we're installing it in this one, and they're separate from each other.
Cool.
So that'll take a minute while it actually locks the database and does the installation. So oh no, there it goes. It's installing right now. Now, fun little fact there. Oh, it didn't do it. But so we got now that this pipenv has the requests library installed into it. If I do venv here, you'll see that one's in a different virtual environment. It's like /demo- some temporary characters, as opposed to the other one. Now, if I do pipenv shell, thinks I'm already in another virtual environment. So alternatively, and what I typically do is instead of using pipenv shell, I source from the pipenv directory the activate script, which does the same thing, puts that virtual environment available for me. And now when I type Python and I do import requests, I have the request library available to me.
Gotcha. Okay. Cool. Thank you.
And so to get out of that virtual environment, you type deactivate. And if you actually want to remove that virtual env directory from your system, just use pipenv --rm, and it removes that virtual environment for us. It's now clean.
Cool.
And that's a quick tutorial on pipenv. But it's really important. I think a lot of new people to Python just think, oh, I'm just going to pip install into my global system all these tools, but you're going to end up with a big mess if you do that, and dependencies will start kind of chomping on one another. And this pipenv tool is pretty handy because it does two things at once, which gives you a way to install packages, and it resolves dependencies a little smarter for you than pip does, and it also makes that virtual environment sandbox for you.
Nice.
The first thing to start off with is basically to start off with good good clean Python hygiene and have nice virtual environments for each of our places we're working in. So speaking of good clean hygiene, there's a lot to be said for keeping your credentials safe. So everything we're going to do with the API, and people who are working with AWS and other services like this will know that there's going to be keys and secrets that you have to keep safe. So on my local machine, I have no secrets written to any disk on my machine. They're all encrypted and stored in a tool called LastPass. Is one I recommend and use pretty regularly. There's other secret storage tools out there, like the HashiCorp Vault, a couple of open source ones that are available. You can use the key tools in Amazon, but to use them you would need the keys. So I use a third-party tool to get my Amazon keys in place, so it's easy for me to access. What's nice about LastPass, so LastPass is like a browser extension, and you can actually log in and store like your Amazon password and your bank password and all kinds of like secure notes into it. But the LastPass organization itself has an open source project for the LastPass CLI. So from the LastPass CLI, you can now access your LastPass data over the command line and then pass it into scripts and do other things with it. And that last piece here is this lpassenv will actually take specially formatted notes on your LastPass entries, and I'm going to show you how that works, and can import them, or take that back, export them into your environment, so you can actually have your credentials in the environment while that shell's live, and as soon as you close that shell, your credentials go away. So I made a demo entry here. So if I do show demo AWS, just to give you an example. So this is actually accessing my LastPass vault. I'm currently logged in, and I can grab the notes off of this. And you'll just see here the notes look like the environment variables that would be exported into my environment to be able to use those keys. So if I look at my env and grep for AWS, you'll see that I have, the only thing that has AWS in it right now in my environment is the current working directory where I'm at. So there's no current access keys or secrets in my environment. Now, if I actually export these using that LastPass env tool, well, I'll run it without doing that first. lpassenv. If I do export and then I use that same key, the demo AWS, which is like the title of that entry, you'll see that it actually formats it as something I could eval into my environment. So we'll actually do that. We will just go ahead and eval that. And now when I run my environment and grep for those keys, you'll see that it's actually exported into my environment. But that's the last time I will show you that, because these are not real keys. So when I actually lpassenv export in the future during this demo, I'll be getting real keys and real secrets into my environment so that I can access various AWS resources.
Right, and to be clear, people are watching this right now, so make sure you delete those later.
Oh, those aren't real keys.
Okay, good.
So nothing. You will see no. Well, if all goes well, you'll see no real keys in this demo.
Awesome.
That demo is those are specifically keys that are in the AWS documentation or some documentation I found online.
I know that Graham is immediately trying those keys right now. Aren't you, Graham?
Go for it. They're not mine. Have fun, because they're not my keys. They won't go anywhere. I don't think they go anywhere. I didn't try it. But here's the instructions for installing that lpass CLI onto a Mac. So you just brew install LastPass CLI. If you're on Windows, I'd recommend installing the Linux subsystem. So you can use basically the Ubuntu package manager, and then from there you can install all these same tools. And basically it's a work-alike from Linux, Windows, and Mac, as long as you're using the Linux subsystem. And it also works under Cygwin, I believe. But the lpassenv is another extra bit you add into it that allows you to export your notes field into your environment. Now, one word of warning, anything in that notes field will be evaled. So I assume you would not be doing this with a vault that is not yours. So you have control over those notes fields. So it's fairly safe, as long as you trust yourself. Which for some people, maybe that's a challenge. I don't know. Okay, the next step in this process is basically to get the AWS command line tool, AWS CLI. what's awesome about the AWS CLI is it uses Boto3, so it is Python under the covers that are running this. So the process of actually installing the AWS CLI will grab you all the dependencies you would need for doing most of the work we're going to show off. So I'm going to show you real quick what that looks like. So in my pip file for this project, you'll see I've actually got the AWS shell in here, but it also installs AWS CLI. Well, let's just show that actually. So if I do pip env shell, perfect. So I've got an active virtual environment now. Typically, you just do pip env install AWS CLI, and since I already have it installed, it should just come back saying you've already satisfied it, so you're all good to go, which it did. And now we have the on our command line, we now have the AWS command available to us. So I'm going to actually put into my environment this right here. There we go. So now that I've exported some secrets and keys into my environment, I can do things like S3 ls. And behind the scenes, it's talking to the Amazon Web Services API using Python via the Boto3 library. This is all an open source project. It's all inside the GitHub repositories. But now we have the ability to search for things. If you use the S3 API and do like list buckets, you'll get back JSON. So if you guys are familiar with most of the returns for a lot of these API calls, all the API calls typically, other than like the S3 ones, are going to be JSON. Now, one thing I really want to show you guys is some cool, like that JSON looks, pretty straightforward. But if you actually would like to colorize it, installing the AWS shell, which I'll show you in a minute, installs Pigmentize, the Pigments library.
Ooh,
so if we
nice.
do Pigmentize, minus L JSON, so we can actually now colorize our output. So if we just pipe that through Pigmentize, we can actually colorize and get much prettier output from the command line.
Oh, I like that.
Yeah, it's pretty sweet to be able to get that nice colored output. Now another thing about the AWS CLI is it does use JamesPath as its query language, and we'll use that later in our Python scripts. But the AWS CLI gives me an easy way to start trying out various filters from the command line before I kind of commit to putting it into some code. So for example, I had one up here earlier where I was looking at. I'll put this one on my command line there. This is going to do an EC2 describe instances, so it's going to list off all of the EC2 instances, and you'll see I've got a filter in here for just I want the instance name and I want the ones that are stopped. I'm piping that through to JQ just for coloring. That's another tool I'll show you guys for how to do some querying of the JSON return. But that filter there is actually a JamesPath filter. So we can actually do queries with JamesPath against our environment and get just the instances that are currently turned off. So you should see here that here we go. So client initiated user shutdown. So you should have a status of what, stopped up here. Lots of stuff. Yeah, status, no, that's the, I'll show you another.
Yeah, there was one down, but it said in use.
Yeah, so this actually just queries only for instances on the AWS side that are stopped. Gotcha. I can show you filtering those later. But we'll use JamesPath and then the JQ tool for that later.
Nice.
It is possible to actually use Pigmentize with different color styles. So at this example right here, you can actually use the Monokai color. So that's the same color style I use in my editor. So if you want to get really fancy, you could alias that command to colorize or some kind of shortcut for piping your JSON output from AWS's tools into it for a more colorful experience. And like I mentioned, if you want to do more advanced JSON filtering, that JQ tool. So not only does the JQ tool give you filtering, like this for example right here, the JQ dot, but you could then filter specifically for, well, I got a different example I'll show you. Just here. I don't know how many DB clusters in this one. Yeah, that one's really specific. Well, you can see here, I'm actually using some specific ones to loop through all the JSON that came back and look for ones with a specific group name, so I can see the various group names coming from these group IDs. So you can get pretty intricate with the various queries.
Yeah.
It's kind of these don't. I don't think I have any reservations in here, so I don't know if that one actually would show anything. Yeah, no, it's not going to. But then, so JQ is you can just brew install JQ if you're on a Mac. James Path, you would get that installed for you automatically when you install the AWS CLI tools, and that actually comes with a command line tool for you to use called JQ or jp.py. So that's the James Path command line version of it, and I'm going to show you in code how you can use that from your Python code directly. So again, while you can use it from the command line and code, it's nice because you can try things out quickly from the command line. So for example, if I did jp.py, you can see here, like for example, I have a file in my directory called tablemappings.json. Let me just make the, I'll make it smaller so you can kind of start seeing what happens. But if I pass it in a filter for just the rules, it's going to filter out just the rules, which didn't seem like it did much for us right there. But if I do the jp.py, like this is going to filter out on object locator looking for schema names. So you'll see now I've actually grabbed all the schema names out of that JSON.
Nice.
It's still a little messy because maybe I want to get just a list of the schemas. And so that's what the last example here is, where I actually pipe that output to a data structure I want. So this is all James Path, and it's well documented in their docs. But I'm basically taking this output, piping it to a list, and that gives me a nicely formatted, perfect list of the schema names that are in that list. And I'll show you what that file looks like, because we're going to use this as part of our example. So you can see here there's a JSON file that contains key rules, which has a list of selections, which then has an object locator with the schema name. So it's kind of buried down in there, nested in there, the names of those databases. And so if I want to grab those out, James Path lets me do that really quickly. So if anybody's familiar with the AWS database migration service, this is the table mappings format for specifying in your task, which database schemas you want to migrate and include in your migration. So if you're doing a bunch of database migrations, this is pretty handy because you can start manipulating that JSON, or we'll show you later, I use it actually to dump the structures and build tasks in an automated fashion, because I may chunk up a migration. If a database has 500 different schemas in it, I may only do them 100 at a time or 50 at a time to reduce the load across the system as I migrate them from one to another.
Gotcha.
So that's some of the advanced JSON filtering. And then one last little treat I wanted to show you guys, if you're not familiar with this, the AWS shell is really, really cool. So let me go to this shell over here, and we'll do, I'll just activate this environment. There we go. And now I'll run the AWS shell. And what the AWS shell does is gives you a nice little UI in your terminal for playing with AWS APIs. And it'll autocomplete, and it will give you documentation. So here we go. I'm logged in. Hold on, though. I have the demo keys still. That's no good. We don't want demo keys. We want some real keys. So if LastPass periodically times out, because it doesn't keep you logged in forever, it will then prompt you for your master password. There we go. And so now I'll do AWS shell again. Okay, so like I showed before, and you can see here the little autocomplete drop down. If I actually wanted to pick from different services, and I can do describe instances. Oops. It does support fuzzy matching. So you can do that right from the command line. Oh, it shows me, oh, I don't have anything running in this specific instance. But if I do S3 API, and now do list buckets, you'll see I do have some buckets in this one. Now, when right behind the scenes, it's actually caching the documentation. And as soon as that documentation is available, as soon as you type in, for example, EC2, that's not working right now because it's not cached fully, you would actually get a pane that would open up on the bottom, and it would show you the docs for that, like kind of the man page for that specific API call. So for example, DMS, it still hasn't cached completely. Let me restart it, see if it goes better. It's still caching the names in the background. We may come back to that, and I'll show it to you later while that gets cached. But that's the AWS shell. For people who are new to the API, it'll actually cache return values. So if you got a list of EC2 instances, it would cache, for example, the instance IDs, so you could then use them in later commands. Another thing I didn't show is you can pipe output. So this list buckets, if we wanted that to be colorized, we can still pipe to JQ, and it will colorize inside the AWS shell, which is pretty handy. I'm just surprised it has not gotten my API docs listed yet. That's too bad. I was really hoping to show that because it's really slick. Still not doing it. All right, well, I'll skip that for now. We'll come back to it. Now, let's get into actually building some Python scripts. Some common tasks you may do is automating RDS, so the relational database service. In this case, we're going to build a sample script that will create 10 serverless Aurora instances for us with one command. Maybe you've got to build a database clusters, or you're sharding your database across multiple databases, and you need a way to spin up multiple ones that are identical. Clicking through the UI can be tricky and definitely error prone as humans, because we're definitely not good at repeating things twice the same way. I was hoping that would still work. It doesn't work. It's all right. So let's do this. I am logged in with the correct AWS account right now. In this directory, well, actually, first I'll go over the code with you. I'll at least give you an intro to the code. So we're going to look at this create serverless clusters. And this is where I told you the batteries included part is really nice. We're going to use the CSV library that's built into Python to basically capture the username, the instance names, and the passwords as we generate them. So we're going to generate databases, and on the fly, we'll generate unique passwords for every database, and then we'll output them to a CSV file that you could then put into your system, or use to transfer whoever the developers are who need those databases. We're going to use a third-party tool called PWGen for generating passwords. It's a tool I've used for ages from the command line, and someone made a Python implementation of it. And of course, we'll use Boto3 to connect and talk to AWS itself. So the first step in most AWS scripts that you'll write is going to be creating a client to talk to AWS. In this case, you'll use the Boto3 library. So when you type import, that imports the Boto3 module into your code so it can now be used. We'll create a client passing it what service we want. And this all has pretty close analogs with the AWS CLI. So kind of the equivalent of this is typing AWS space RDS, and now we have a client that can do operations against RDS. Now the next line here, for people who are not familiar with Python, this is actually a generator expression. So this stands in for basically a for loop. You'll see that there is a for in here. So we're basically looping over range 10. So again, the range function just gives you back a list of, I'll show you right here, Python. So if we do range 10, now since we're using Python 3, we get back a range object, but really under the covers, not under the covers, but what it'll do for you, it'd be like this. You get a set of integers from 0 to 9, so 10 integers. So DB gets set to each of those numbers as we go through. And because this is a generator, or a generator expression, it's going to create a dictionary for us. We're going to create a dictionary with a key being the host name or the instance name of the database we want, and I'm padding that number with a 0. So, for example, it'll be SAS00, SAS01, SAS02, and then I pass in the number that's coming from that range. And for now, I set the value of that key to nothing. So we're just going to end up with a dictionary that has keys being the names of the database instances and the values currently being nothing, which later we will set to the password. So when you're writing, these are all pretty simple command line scripts. I'm going to the very bottom here. Oops. You know what? This is I've not gotten there yet. So we'll talk about that next. The next example has that a little more formalized how you write these. But for this script, what it's going to do is going to execute from the top to the bottom. So first things first, creates a client. Next thing it's going to do is create that new DB's dictionary. Then we will loop over that dictionary all the keys. So each of the instance names will now become the DB variable inside this loop. And so we'll grab that first, the entry that lines up to the first key, and we'll call pwgen and generate a 20-character password and set that as the value. So the dictionary is going to be instance name and then the value being the passwords. And now we go to do the real work, which is basically calling that client, calling create DB cluster, which is the exact same command line option you would have from the AWS CLI. But the benefit we have of using Python is we can now type out in a much easier to read format all the various arguments for the API. So for example, which availability zones it'll be in. This is all pretty standard stuff. If you guys haven't created the serverless Aurora databases yet, the engine will be Aurora and the engine mode is serverless as opposed to provisioned. And then you don't have to specify what type of database it is, whether it's like Postgres or MySQL, because the default's to the MySQL one only right now. And then we use that master user password that we generated right here. So we basically recall that in that dictionary, we want the value for this database, pull up that password. And then at the very end, we make sure we got deletion protection on. Now, once we're done creating all the instances, we are going to loop over that dictionary of databases where we have the new passwords in them, and then we're going to write them to that CSV file. So we're going to use a context manager here. So this with keyword in Python basically opens up a context manager, and the benefit of that is we don't have to worry about closing the file later. So as we unindent from this code block, the file gets closed for us automatically. So F is going to be our file handle. We're going to create a brand new file called newdbs.csv. We will use that built-in CSV module to produce a writer. And luckily, the writer handles dictionaries really, really elegantly. So for calling items on that dictionary will give us back a tuple of a key and value. And then those will just get written to each row. So as we loop through, this is a list comprehension at the bottom. So at the very top, if you remember, we use a dictionary generator dictionary comprehension up here at the top. And at the bottom, we're using a list comprehension. So the difference between the two is going to be the square brackets versus the curly brackets. And in this case, every row is going to be the tuple, the key values, the database name, password. So why don't we go ahead and try this? This maybe will make be a little clearer once we run it. So if I run, so when you call Python while you're inside of a virtual environment, it uses the Python in your virtual environment automatically. You don't have to worry about which path it's in. It's going to be all taken care of for you. So if we call create serverless clusters, just for fun, I will put the RDS control panel up here so you can see it happen kind of in real time. This should work. Yeah, there we go. I'll put this over on the side. There we go. So this should start populating once we run. I'll move this over to the side here so you can see them both at the same time. So we'll call Python create serverless clusters. Oh, I'm not in the right account. No, it's not in the right account. Let's try this now. There we go. So there's a couple things that are still hard-coded in this script that you may want to watch out for. I'll talk about those as we go up here. So for example, the DB subnet group name. That's hard-coded, and same thing for the VPC security group IDs. Those will be unique to your accounts. If we refresh over here, you'll now see we've got
Boom.
10 serverless instances, and they are all creating right now. So
the middle section, the for loop, that looks a little bit like a CloudFormation template. Are they similar?
Well, I think what's nice about all the Amazon tools is they all share these same arguments.
Mm-hmm.
If you looked at the actual REST API directly, if you were to call this posting the specific structure you were supposed to post, you'll see these exact same formatted variable names. So what they've done is basically made the arguments to the Python function match exactly the arguments you would pass in as key value pairs in the
Nice.
API.
Very cool.
So I assume they've done something similar with the CloudFormation stuff. Yeah, so they are still creating. They'll take a minute or two to fire up, but once they're up, I'll show you a quick command line tool for deleting them all very quickly.
Before they start charging you.
Yeah, well, luckily they're serverless, so they're going to run for, 5 minutes, and if there's no connections, they'll just shut down. So if you guys haven't messed with the new Aurora serverless, it's kind of nice because it'll auto-scale up database backends for you, and then it'll scale down, and it actually will scale to 0. So if you have no connections over a weekend, maybe it's a business hours only app, at night and weekends, it'll automatically scale to 0, and you basically only pay for the storage. I know I sound like an AWS ad, but it's pretty cool technology.
And where does it keep the stateful data? Where does it store data at?
So it uses EBS.
Okay.
There's block stores behind the scenes where it manages. If you guys have already been using the Aurora databases, not the serverless version of it, you know that it will automatically grow the data store in demand for more storage. So the same technology is used here, but then the front ends will just disappear when there's no requests being made for it. So it's kind of like a Lambda. If there's no running instances and someone makes a database connection call, it may take up to 30 seconds for that database engine to spin up to service the call, but it will spin up and then start servicing calls until there's no connections for some amount of time.
Nice.
Yeah, so it's pretty interesting. So yeah, these should be created soon, so we can show you. Yeah, they're all available. So now I'll show you how to delete them. Because if you tried to delete these right now, let's do this. I'll make this bigger so you can see it all. There we go. So if we use the AWS command line tool, RDS, well, I'll use AWS shell because I can't run the commands. So if we do RDS, list, describe DB instances. I do not want to delete yet. There we go. So this should show our 10. I didn't show it for our 10 here. This is the one where I ran the command, right? Yeah, it is. Oh, you know why? Because it's not DB instances. These are serverless. These are clusters.
DB cluster.
Describe DB clusters. There we go.
There you go.
So we now have our 10 DB clusters. You'll notice that deletion protection is true. So if we actually called the delete API call right now, it would give us back an exception, an error, saying we cannot delete them. But if we use, I've got another tool we can use for that. So from the command line, we can use some good old, just shell for loops to handle this. Wrong window. Here we go. If I paste this in here, I'm going to use some major command line foo with some JQ querying to basically query for cluster identifiers that start with SAS 0, in case I had other instances that are in there. And then I'm going to modify the cluster, turning off the DB protection. So that's what that last bit of the line is doing right there. And done. So I'll take a moment, and you'll see now that the deletion protection is false for each of these instances as it outputs it. And then once we have DB protection set to false, we can now call the delete, which is really similar. we're going to do the same kind of query. Oops, I think I'd stop doing that. There we go. And so now we call basically the same loop, calling delete DB cluster, passing it in the DB identifier. So the whole idea with this JQ query here is to get that DB identifier, because that's what we need to be able to do the deletion. Mm-hmm. Yeah, if I pull up that, we should now see them being deleted. Yeah, there you go. They're starting to delete. And eventually they'll all go away. So there's kind of a quick intro to deleting databases for you.
Don't try this at home, kids.
Well, be very careful if you do. You know what they say, to err is human, to really mess up requires DevOps?
That is entirely accurate.
Okay, let's get back to the presentation. I want to make sure, yes, so the next thing we're going to do is we're actually going to take and automate some shell commands. So we're going to use data from Amazon. That was the table mappings from the database migration service. Mm-hmm. The use case here is, for example, with the database migration service, it does not automatically move over things like foreign keys or auto increment or stored procedures. Those things you have to do beforehand before you move the data. So a common technique is to dump just the structure of the data, apply that structure to your target database, and then run the database migration service across it so that it's basically pre-populated and ready to go with all the schema, and then you just load the data into it. So I want to show you guys how we can actually take over adding that structure from a set of data coming from the table mappings. So like I mentioned before, in this table mappings file, this is what you would feed Amazon in the DMS task. So if you were automatically creating the task, you would actually feed it this JSON file, and it would set it up for you. We are going to create a Python script to dump the structure for us. And we're going to use the subprocess built-in. So these are all three built-in modules of Python itself. Again, that battery is included. We have the ability to process JSON. There's a time module built in, and then we're going to use subprocess to allow us to call out to a shell and run a specific command. These next two are add-ons, like modules we've installed, one called Click, and that's a really awesome tool for building command line interfaces. If you get one like super awesome tip out of this presentation, it is to use this tool called Click for building quick little scripts. And then we're going to use JamesPath to query that JSON to pull out that list of schemas from that nested structure that's currently embedded into. Now, the common technique for building command line tools that you saw when we did the tool down here, for example, we ran the Python command passing it the Python script we wanted to run. What if we actually wanted to create command line tools just like the AWS tool? That AWS tool is written in Python, but you just type AWS. You aren't writing Python space AWS to run it. So we want to be able to build our own command line tools that can take arguments, and you can pass it in different parameters, and be able to customize it so it can be used a little more generally. So when you do that, you'll see that if you're running it as a command line tool, Python will basically run it with this special variable under name equal to main. And if it does that, it means it's running as a program and not as a library. A subtle difference there, and as you get into building your own tooling, you'll learn how to build your own libraries, and then the difference between that and building a command line tool like this. So in our case, our running of the tool will call this one function called dump DB structure, which we've defined up here at the top. Now, normally when you're creating command line tools, you'll use a built-in from Python called argparse, and it's a little tricky to use, and it's very verbose. You kind of get a lot of boilerplate going. The Click library simplifies that. It uses the Python decorator syntax, so you can actually decorate any function you want with this first one right here, this click.command, and that turns it into a command that you can run from the command line and specify, for example, arguments. So we can actually specify our command line arguments as click options. So we're basically stacking decorators here. The first decorator has to be the command one. The subsequent ones are going to be our command line options that we'll pass in. So we can pass in user and password. This way I don't have to hard code passwords into scripts. I always make my passwords an argument that I can pass in from the command line or as a prompt, you'll see there's an extra option here for prompt equal true. So it'll actually ask you for it, so you can then just paste it in. And you see that it also has the ability for you to hide the input. So if someone was trying to shoulder surf, you can actually build your tools in a way that they can't see what you just pasted into the command line. And then we can post in our host, our mappings file, and then those become the arguments for our script automatically. So you can see right here, our arguments for our function, our method, our function here is user, password, host, and mappings. That click library does all this mapping and basically hookup of those variables for us. So when you put in here -- user and -- password, that maps automatically to user and password. Same thing for host and mappings. So we're going to use our context manager. So we open up that mappings file, and when we exit that with statement, it automatically closes the file for us. So we don't have to worry about file handles and things like that. We will load that mappings file as JSON. So we're going to use the JSON built-in inside of Python to load that file. And that gives us back a Python data structure. So it'll be the equivalent of that JSON, but in Python data structure. So a JSON mapping will become a dictionary. Array in JSON will become a list. And now we can actually use our James path to search for the specific schema name. So this is the exact same filter I did from the command line. So actually I tested this out on the command line first, got it so it was returning that list of schema names, and then I just pasted it into my code. Because saving and then rerunning and saving and rerunning can be a little tedious when you're just trying to figure out what this query is supposed to look like. So doing it from the command line speeds that process up greatly.
Quick question. Oh, Calvin?
Yes.
Yeah, sorry, I have a quick question from the audience. Do functions need to be defined before they are used, or can they be defined in any order?
They need to be defined before they're used. That's actually why this is at the very bottom. So we've defined the dump structure above, so that when we get called as a program, we can actually use it. If we put this above, it would be like no such name defined dump DB structure. So yeah, it has to be defined ahead.
Awesome, thank you.
No problem. We've got the basically DBs is now that list of, well, if we look down here, if I did that py or jp.py, this structure right here is going to be passed to our new variable called DBs. Helps I move the right terminal there. Now we're going to take that structure and we'll use it here in a minute. To use the subprocess command, so you'll see right down here, we're actually going to open up and call that command using subprocess popen. Popen expects a list of the command plus any command line arguments. So the first item of the list is going to be the command we're going to run. So we're going to run MySQL dump. We're not going to export any data. We're going to do a compact. We're going to grab all the stored procedures. And here's where we pass in those variables. So the host or user and password that came in from the command line or from the prompts are going to be passed in directly here as variables to our MySQL dump command. So this is an easy way to template those kind of long, big, tedious command line args. You may want to do this so you can just reuse it. Now I can run it against 5 different databases with different hosts and different usernames and different passwords. You'll notice this is new to Python 3, this F in front of the little string. So you guys recognize this is a string. This is called an F string. And that's kind of the new way of basically substituting variables into strings in an easy, quick to use templated format. So the curly braces denote like where that variable is just going to go. Some people maybe
so much easier.
Oh yeah, it does. F strings are very nice. I'm a fan now. And then the very last bit down here is we actually are going to pass it in an argument for the databases. So this is the name of the schemas we want to dump. And we don't want to dump, so if there's 500 schemas in here and we only want to dump 10 of them, we can pass in here just the 10 databases that we want to dump. So we're going to take that list of databases, and we're using a method on a string. So you see the 2 single quotes here with a blank space in between? That is a string, and the strings by default have a method called join, and you pass it as some kind of sequence. And what it'll do is it'll take that sequence and make a new string, putting whatever's in these quotes in between it. So we're basically going to make a space-separated list of databases on the command line.
Gotcha.
So that is the buildup of our command. We're gonna want to output to a SQL file. The output of this, basically normally it goes to standard out. So you would redirect that to a file if you were doing it from the command line. With Python and using process popen, we can actually redirect standard out to some Python object. In our case, we're going to open up a dump file, which we generated a name here based on a timestamp. And we also use the host name, so we get a unique file per host and time we run this script. So you can run it over and over again, and you won't clobber a pre-existing run, kind of a little safety measure there. So we're going to open up a file-like object, or a file technically, for writing. And then we're going to run our process. So the subprocess command has or subprocess module has a popen function to it. We pass it in our sequence of the command itself, and then we redirect standard out to our file. So this is equivalent of doing a greater than symbol, and then passing all the data from our command into a file.
Gotcha.
Now what I'll do is I'm going to go ahead and run this, but I'm going to comment out this line because right now I don't have MySQL dump installed on this computer, but I can still run it and show you what the output's going to look like. You just comment that out, because what I do is here is for debugging. I put a couple print statements in here to say what it's going to execute. So as I'm developing it, I can kind of get like a no-op version of it to see what's going to happen, because better safe than sorry. So if we run this, so we'll do run Python dump structure. So I can put in there Calvin, some password, host 1. Oh, and then so it does have required arguments. So for example, you know what? I don't need to run it with Python. This is a command. Oh, you still have to make sure it's executable.
Chmod.
There we go. Oh, it didn't like that. It's not happy with me. All right, we'll run it like this just for now. Dump structure. Oh, but so I want to show you with that click library, you automatically get usage instructions, which is really handy if you do -- help. So that click library automatically generated this usage command line tool usage for us. And we'll see that mappings is required, and it won't prompt for it. So we'll just do this, table mappings. And now it's output. I had it output what the command is going to be specifically. So you can see here, it's the full MySQL dump command with all the databases listed as the last argument. So it's super handy for generating pretty complex and tedious things where I don't want to copy paste names of databases, and I may get extra characters in there. Here I'm just going to deal with the data file that was given to me from Amazon, and build up the thing programmatically.
Very cool.
Yeah, that's pretty a favorite of mine, the automating shell commands like that. And the last, so I have one more example I want to show you guys before we get going, is tracing CloudFront logs. Sometimes you want to build little tools to be able to get data out of Amazon a lot easier. So if you guys have ever looked at the CloudFront logs, you'll see that it's a giant CSV file with a bazillion columns. I'm not kidding. There's a ton of, you guys ever looked at it, but there's a ton of columns on there, and it's really hard to decipher. It's especially if it's all just plain text and you're looking at it in a plain text editor, or even if you load it in Excel, it can be really tricky to look at. And sometimes you may want to be able to find a specific transaction ID buried in that log and see what the value for it was. So we built some tools. I actually put it up on our GitHub already. So this one we're going to go into and look at directly. So I'll open up the editor here. I'm in a different environment, so I have a separate pip file for this project. It was actually this used to use pip with the requirements file, but I've kind of really grown to love pipims because I get the whole virtual environment thing included. So this will look somewhat similar. Actually, this is using the older argparse, so I could upgrade this to use the click library. But I am using another really cool library in here called Clint. And the Clint library will give us some fun colored output to our command line. So we can actually use it to prompt us for a question, and then I'll use it to basically format the output with colors so that it's easy for us to read. So very similar. We're going to use Boto3. We'll use the gzip library, which is built into Python. Again, batteries included. You can actually uncompress file objects on the fly, so you don't have to like unzip them, then read them. You can actually do that through Python directly. In this case, we're going to create a session. That's a little bit different than what we did last time where we created a client. We're going to create a session object first, and then we're going to access S3 over that session because we're going to do multiple operations across multiple requests instead of just doing one request like we did in the previous example. So in our case, we're going to create a new session for Boto3. In that session, we're going to open up an S3 client, and then we'll use S3 client to list objects in a bucket. In our case, we'll pass it the name of the bucket, and we'll get out the prefix for the prod CloudFront logs. Now we'll use the Clint library has a prompt built into it to actually ask us for input, and I'll show you. I'll do a quick demo and show you what that looks like. But basically, we can pick which log we want to view, and then it'll re-ask S3 to grab that object. So we'll go grab that log file, and then we can use our context manager to open up the file. So in this case, we actually have to uncompress it because it is a gzip file, and we'll uncompress it, grabbing the body of the file, so the contents of the CSV file, and then we're going to parse it. And so since it is CSV, or a file, or just a regular file, we can use the read lines of the file to grab all the responses. So we put a header on top, and then I put all the data down below. So you'll see a nicely formatted with colors.
Oh, that is so cool.
Yeah, so let me run it. It's probably more impressive when I run it, and you can kind of take a look at the code yourself later.
I'm literally going to use this like as soon as we finish this webinar. There's some log files I need to monkey with.
So I'll do, let's see, I forget which one oh, here we go, SFU logging. So I couldn't remember the bucket name. So basically you have to pass it in a command line argument for the name of the bucket where your CloudFront logs are. And once you do that, ours is kind of big. It's got over 1,000 entries in there. But you could pick any one of these ones you wanted. You can see they're all date time stamped, so it's kind of easy to find where they are. In this case, I'll just pick number 999. And then the next subsequent request is going to go grab that file, unzip it, and then show me the contents of it. And you'll see it's all nice and colorized. And you can see that, so it puts a header on there for us, so it's easy for us to read as humans. And a lot of times what I'm looking for, in this case, if you've ever debugged CloudFront, you're trying to figure out why you're getting hits, why you're getting misses, why you're getting redirects, and this helps you trace where they were going to, whether they got a hit or a redirect. And then if you want to trace that further, you can use this request ID to look down the line for where someone was coming from or going to. Or maybe you request it in your browser. You can look at the headers that came back to your browser and find that request ID and then go search for it in the CloudFront logs. So that's pretty handy. I think I've written another little tool in here for finding a request ID. So in this case, we can actually pick up a specific CloudFront log and start looking for all instances of that request ID in there. So it's another example script that's in here. And you can say, if it finds it, you'll put a little found and then shows you the output of it. I'll save full CloudFront tracing for another brown bag if you want.
Dude, as many of these as you want to do, this is fantastic. I've got a couple of comments in the from the audience. My code has never been so beautiful.
Well, I would like to thank Python for that. I think it helps you with good code style. That's kind of the end of this. I've really got there's some resources here, which is basically the Boto3 documentation, the CLI reference, and then James Path reference there as well. And I'm definitely open for questions. I love doing this stuff. It's been a lot of fun figuring out the APIs and be able to basically interoperate with the infrastructure as code is super powerful.
Yeah, definitely. I mean, this is absolutely fantastic. This is hold on, let me I'm getting either questions or chatter in the queue. Please for more. Yeah, yes, please do more. Some responses in Twitter. Wow, this is fantastic stuff. Not necessarily questions, but so when there's not a ton of questions, it either goes one of two ways. Either everybody is completely asleep and glazed over, or it was so in depth and amazing that they're just like in stunned silence. And I definitely think that this is the latter, because this was an absolutely fantastic presentation. Thank you for doing this. This was.
Oh, you're welcome. And the code will all be in GitHub, so that you guys can go take it all in later, so you can play with it, try it out.
Somebody saying, yes, was a great presentation. I'm in awe here.
You're going to make me blush now, Chris. You need to stop.
Oh, go on. Stop. Tell me more. Solid work. Thank you. Yeah, no, it's now Graham saying now I have to go. Now I might have to go learn Python. Yes, Graham, you might.
Yes, you do.
Did you mention that you're the leader of the IndiePy at the beginning of this, Calvin?
Oh, I did not actually. So I run the local Indianapolis Python user group called IndiePy. I also run the local AWS group, which is how I met Chris, was through the AWS community. The IndiePy group will start live streaming our sessions soon, so look for that. We do 3 sessions a night on the second Tuesday of the month. So we'll have beginner talks, we'll have right brain talks, we'll have pro talks, and we are going to definitely start live streaming.
Oh, I've already signed up for your meetup, even though I'll never be able to attend live.
I was like, that guy's from far away signing up for our meetup.
A little bit off the beaten path. But if you're going to be live streaming it, then I'll definitely be watching. Cool. All right. Good. Not on Wednesdays. Nice. Yeah, we wouldn't want them coinciding with the vBrownBag.
No, definitely not.
Cool. Got a link to sign up. If you just Google IndiePy, it's literally the first thing on there, INDYPY, and it'll pop up as the meetup. You'll be able to join from there.
And all of our sessions are on YouTube, so you actually just go to YouTube and search for IndiePy as well. You can find hours and hours and hours of video there.
Yep, totally. Cool. All right. Well, again, Calvin, thank you very much. If anybody pops up with questions on the YouTube or anything like that, then I'll be sure to either try to. I'll give it the first shot to try to answer them myself, but then I'll pass them on to you because I'll.
Okay, and then my Twitter handle's on there too. So if anybody wants to ask me a question on Twitter, I'm just Calvin HP on Twitter.
Oh, there you go. I will remove myself from the equation. Automation. There we go. Perfect. Calvin, again, thank you very much, and have a wonderful evening.
Thank you very much. It was a pleasure, Chris. I really appreciate you having me on.
Awesome. Bye-bye.